The company introduced its first Krait CPU core way back in 2012, and ever since then the Krait core has been the brain of most of the successful Android and Windows Phone devices. A custom creation, Qualcomm designed the Krait core under ARM's architecture license, meaning that it only used the very basics that ARM provided like the instruction set, while for all else it was Qualcomm engineers who were charged with the task to carefully tweak performance to come with an efficient and powerful core. This year, with the Samsung Galaxy Note 4 and the Nexus 6, both equipped with the latest Snapdragon 805 featuring a refined Krait core, we're seeing the swan song of this 3-year-old CPU design, the Krait 450. The latest big jump in performance for the Krait family of processors happened with the release of the Snapdragon 800, also known as the MSM8794, a chip that appeared on devices like the Samsung Galaxy Note 3, Nexus 5, and Sony Xperia Z1 in 2013. The Snapdragon 800 debuted the Krait 400 core. A very similar Krait 400 CPU core was later used in the Snapdragon 801, that in turn brought the increase in clock speeds, from about 1.7 GHz in the previous generation Krait cores to 2.3 GHz on the Krait 400. The main reason for this substantial boost in clock speed was the change in the manufacturing process. While earlier Snapdragon chips were made on the 28nm LP, low-power, node, the Krait 400 was the first to be made on a 28nm HPM, high performance for mobile, node. At the same time, it's worth keeping in mind that Qualcomm did not make any huge changes in the underlying Krait core architecture, leaving instruction parallelism on the same level. This was a short run through the facts that lead us to the Krait 450 design. It's important to remember all those things when speaking about the Krait 450 as it is a gradual build-up from the Krait 400 core. The particular implementations of the Krait 450 on the Samsung Galaxy Note 4 and Nexus 6 run it up to 2.65 GHz. We're looking at the same 3-wide decode, 4 issue with 7 execution ports and 11-level deep pipeline architecture as in previous Krait cores. On board is also a 32 KB of L1 cache, 16 KB instruction and 16 KB data, as well as 2 MB of shared L2 cache. Looking over to multi-core performance, the Krait 450-based Galaxy Note 4 and Nexus 6 score around 3,270 points on Geekbench, while the Krait 400 running LG G2 averages 2,750. Here, the improvement also measures to around 19%, which is, logically, consistent with the boost we saw in single-core performance. After all, both the Snapdragon 805 and the Snapdragon 800 use a quad-core setup. The grand finale of the Krait processor and the slow demise of 32-bit is clearly the main topic of discussion around the Snapdragon 805. It's the best out of Qualcomm's 32-bit series. Yet we've seen other companies like Apple and Nvidia set a new benchmark with larger cores that have a hugely better single-threaded performance. At this point in time, we're more excited about the bigger changes coming with 64-bit Android than we can be excited about the gradual improvements in the Krait CPU. The Adreno GPU, on the other hand, shows that it is a powerful solution that will enter fierce competition next year with other rivals. However, there is one big reason why Qualcomm should not be too troubled about the future. It has only grown its lead in baseband, after an early move into LTE and well-invested R&D dollars in multi-mode modems. MediaTek is the big rival in this segment, stealing away the market for cheaper devices, and we're looking forward to seeing how will Qualcomm respond to that threat. Looking forward to 2015. There is a lot to be excited about, the first chip on a 20nm process, the first 64-bit chips, and naturally, Android 5.0 Lollipop devices with 64-bit support. We've also heard that the new custom CPU core by Qualcomm is coming, and we might hear more about it as well. Thank you for watching. Please subscribe for more reviews. And I will see you guys in my next video. Until then,